In this video, I'm going to show how you can integrate geometry in algebra using trapezoids and truncated cones and using vocabulary that's important to calculus. Okay, for this problem, we're going to find the area formed by the y-axis, the x-axis, and the equations y equals x plus 4 and x equals 6. So here we have our y-axis, here's our x-axis, the equation y equals x plus 4, we're going to start at 1, 2, 3, 4, and then it has a slope of 1, so it's going to go like that, and the line x equals 6, so it's a vertical line at 1, 2, 3, 4, 5, 6, right here at 6. Okay, so when we see this, there is our enclosed region. We're going to find the area of it. It is a trapezoid. The height here is, this measurement is 4. This is 6 right here. And this length we can count as, and when we count it, we come up with it being 10. So when we go to find the area equals 1/2 b1 plus b2 times our height. So the area equals 1/2, b1 is 4, plus b2 is 10, and the height of our trapezoid is 6. So the area equals 1/2 of 14 times 6. So the area equals 42 centimeters squared. Okay, this next problem asks me to find the volume when the region that we just created is rotated about the x-axis. So we have this region, and now we're going to bring it around, rotate it around the x-axis. So what's going to happen, this is is we're going to get this shape that looks like the bottom part of a cone, like the top part's missing. It's called a truncated cone. You can see it looks like this top part here is just missing from a regular cone. So the way that we're going to find the volume is we're actually going to find the volume of the whole big cone and take away the part that's missing, which is the top part. So we're going to find the volume of this part right here. And since my line is formed, it has a slope of 1, what I did is I continued it, and I found that now I have the whole cone. So the way that I'm going to find the volume is, my volume is, for the cone, it's 1/3 pi times Now in this case, I'm going to call it with a capital R squared, capital H, which is the whole cone, minus the little top. Little r squared, little h. So I'm going to factor out the 1/3 pi, and then I'll have capital R squared h, the big cone, minus little r squared h. Just make the math a little bit easier. So 1/3 pi, the radius of the big cone at the bottom of the cone here is 10. So it's 10 squared, and the height here, we know that this is 6, and then when we count over here, there's 4 more, so that whole height there is going to be 10. That. Minus the little cone, the radius of the little cone is 4. And the height here of this little cone is also 4. And so I get the volume is 1/3 pi times 1,000 minus 16 times 4, which is 64. So my volume is 1/3 pi times 936. Divide that by 3, and my volume is 312 pi centimeters cubed. So the way that I solve this problem to find the volume is I'm missing the top part right here. So I have the bottom, so what I did is I found the volume of the whole cone and took away the top. And that's how I found the volume. Now this problem, we used geometry and algebra. It also could have been done using calculus. Okay, but I'm just focusing here on the algebra because it's something that could be done by high school students before they get into calculus. But that concludes this video. Thank you.